All right, so let's go ahead and take a look at lesson 9.3, solving quadratic equations using square roots. So when do we want to solve a quadratic equation using square roots? Well, we want to do this when our b value is 0. Remember that the standard form of a quadratic equation is ax squared plus bx plus c equals 0, where a is the coefficient of x squared, b is the coefficient of x to the first power, and c is a constant, a number being added or subtracted. So notice here in these three examples that there is no x to the first power, and that's because b is 0. So that is a good opportunity to solve the quadratic equation using square roots. So looking at this first example here, A, normally when we talk about solving quadratic equations, we want the equation set to 0. But in this case, when we're solving using square roots, we actually want to isolate the x squared. So our first step here in solving 3x squared minus 27 equals 0 is going to be to get rid of this negative 27. So we're going to add 27 to both sides here. And that's going to leave us with 3x squared equals 27. And so now our next step in isolating x squared is to divide both sides by 3. And that gives us x squared equals 9. And next, we don't want x squared, we want x. So we need to find the square root of both sides. So the square root of x squared is x. And the square root of 9, remember, numbers have two square roots, the positive and the negative version. So the square root of 9 is positive or negative 3. So in this case, we have two solutions because x can be positive 3 or x can be negative 3. Looking at this next example, B, we have x squared minus 10 equals negative 10. So in order to isolate x squared, we're going to add 10 to both sides. And this gives us x squared equals 0. Once again, we don't want x squared, we want x, so we need to find the square root of both sides. And the square root of x squared is x, and the square root of 0 is 0. So in this case, we only have one solution, x equals 0. Now looking at our third example here, example C, we want to solve negative 5x squared plus 11 equals 16. So first we want to get rid of this 11, so we're going to subtract 11 from both sides. And this gives us negative 5x squared equals positive 5. Next, we want to get rid of this negative 5 here, so we have to divide both sides by negative 5. And this gives us x squared equals negative 1. And then once again, we don't want x squared, we want x, so we need to find the square root of both sides. So the square root of x squared is x. However, we cannot find the square root of a negative number. Because remember, whenever we multiply a number by itself, the answer is always positive. Positive times positive is positive, and negative times negative is also positive. So we cannot find the square root of a negative number with a real number. So there is actually here no real solution. So we can see here that there are three different types of answers that we could end up with when we solve a quadratic equation using square roots. For example, in example A, we had x squared equals 9. So if you end up with x squared equals a number greater than 0, then what you're going to have is two solutions because the square root of any number is positive or negative. So whenever x squared equals a number greater than 0, you're going to have two solutions. In example B, we see that if x squared equals 0, then you have exactly one solution, and that solution is always x equals 0. And in example C, whenever x squared equals a negative number, then the answer is always no real solution because there is no way that you could find a real number square root of a negative number. All right, so go ahead and pause the video here and try to solve questions 1, 2, and 3, and then unpause and see if you got it right. All right, so looking at number 1, negative 3x squared equals negative 75. Our first step in order to isolate x squared is to divide both sides by negative 3. So negative 3x squared divided by negative 3, that is x squared. And negative 75 divided by negative 3 is positive 25. Next, we don't want this x squared, so we need to find the square root of both sides. The square root of x squared is x. And the square root of 25 is positive or negative 5. So we have two solutions here. X equals positive 5 and x equals negative 5. So now looking at number 2, x squared plus 12 equals 10. In order to isolate x squared, we would need to subtract 12 from both sides. And this leaves us with x squared equals negative 2. Now, normally we would find the square root of both sides here, but we already know that we cannot find the square root of a negative number, so the answer here is no real solution. Now moving on to number 3, 4x squared minus 15 equals negative 15. We're going to add 15 to both sides. This leaves us with 4x squared equals 0. Then next thing we're going to do is divide both sides by 4. We get x squared on this side. On the other side, 0 divided by anything equals 0. And then once again here, we're going to find the square root of both sides. The square root of x squared is x, and the square root of 0 is only one answer, 0. So we have one solution here, and it is x equals 0. All right, so now on to example number 2, solving a quadratic equation using square roots. But now look at the left side here. Instead of having x squared, we have a binomial squared. The binomial x minus 1 is being squared. So how does this look? Well, let me go ahead and write this over. We have x minus 1 squared equals 25. And again, in order to solve this, we don't want this exponent of 2. How do we get rid of it? We get rid of it by taking the square root. So we're going to take the square root of both sides. So the square root of x minus 1 squared is just x minus 1. And the square root of 25, again, is positive or negative 5. Because 25 has two square roots, positive and negative. So what we end up with here is x minus 1 equals positive or negative 5, which means we're going to have two separate equations. One equation is going to be x minus 1 equals positive 5, and the other equation is going to be x minus 1 equals negative 5. And we solve both of these equations. So we're going to add 1 to both sides here. And we end up, for this left one, we end up with x equals positive 6. And for the second equation, once again, we're going to add 1 to both sides. But this time, we end up with x equals negative 4. So those are our two solutions. X equals 6 and x equals negative 4. All right, so now pause the video, do 5, 6, and 7, and then come back and see if you got them right. All right, so looking at number 5, we have x plus 7 squared equals 0. Once again, we want to get rid of that exponent of 2, so we are going to take the square root of both sides. The square root of x plus 7 squared is x plus 7. And there is only one square root of 0, and that is 0. And so our last step in order to solve this is simply to subtract 7 from both sides. And that gives us our answer, x equals negative 7, and yes, it is that easy. All right, so looking at number 6, we have 4 times x minus 3 squared equals 9. So the first thing we want to do is get rid of this 4. So let's go ahead and divide both sides by 4. On the left, the 4's cancel out, leaving us with x minus 3 squared. And on the right, we're just going to leave this as 9 over 4. There's no need to be scared of these fractions. Next thing we want to do is get rid of this exponent of 2. So we're going to find the square root of both sides. The square root of x minus 3 squared is x minus 3. And the square root of 9/4 is positive or negative 3 over 2, which we can also write as positive or negative 1.5. So let's write it that way. So now we're going to have our two equations. Our first equation is going to be x minus 3 equals positive 1.5, and the other equation will be x minus 3 equals negative 1.5. So in both of these, we're going to have to add 3 to both sides. On the left equation, we end up with our first solution, which is x equals 4.5. And in the second equation, we get x equals 1.5. So those are our two solutions. All right, so now question number 7, we have 2x plus 1 squared equals 36. First thing we want to do is get rid of this exponent of 2. So we're going to take the square root of both sides. So the square root of 2x plus 1 squared is just 2x plus 1. And the square root of 36 is positive or negative 6. So now we're going to end up with two equations. One equation is going to be 2x plus 1 equals positive 6. And the other equation is going to be 2x plus 1 equals negative 6. Let's go ahead and do one equation at a time. On the first equation, we're going to subtract 1 from both sides. And this gives us 2x equals 5. Then we're going to divide both sides by 2, giving us x equals 5 over 2, or 2.5. In the second equation, we are going to start off the same way. We're going to subtract 1 from both sides. But this time we end up with 2x equals negative 7. And then we're going to go ahead and divide both sides by 2. And this gives us the answer, x equals negative 7 over 2, or x equals negative 3.5. All right, looking at example 3, we're still doing the same thing, except sometimes the answer ends up being an irrational number, a decimal that goes on forever. So we need to round. That's why it says approximating solutions. So if we look here, the first thing we need to do is add 13 to both sides. And this leaves us with 4x squared equals 28. Then the next thing we're going to do is divide both sides by 4. And this leaves us with x squared equals 7. And just like before, we want to get rid of this exponent of 2. So we're going to take the square root of both sides. The square root of x squared is x. But 7 is not a perfect square. So the square root of 7 is an irrational number. So we get positive or negative 2.6457, and on and on and on. And it tells us to round to the nearest hundredth. So the nearest hundredth is here, and the 5 tells us to add 1. So our answer is x is approximately positive 2.65, and x is approximately negative 2.65. All right, so go ahead and pause the video and do these 3 problems, then come back to see if you got them right. Looking at number 8, first thing we need to do is subtract 8 from both sides. And this gives us x squared equals 11. And then we want to get rid of this exponent of 2, so we're going to take the square root of both sides. And so x equals positive or negative. Now, again, the square root of 11 is 3.3166247, on and on. And we're going to round to the nearest hundredth, which is right here, and the 6 tells us to add 1, so x is approximately positive 3.32 and approximately negative 3.32. In number 9, the first thing we need to do is add 2 to both sides. This gives us 5x squared equals 2. Then we're going to divide both sides by 5. And this gives us x squared equals 2/5, or 0.4. Then we want to take the square root of both sides. And so we get x equals positive or negative. And again, 0.4 is not a perfect square, so we get 6, 3, 2, 4, 5, 5, 5, and so on. And we need to round to the nearest hundredth. So this 2 tells the 3 to stay. So our two answers are x is approximately 0.63 and approximately negative 0.63. All right, and for number 10, we're going to start by adding 30 to both sides. This gives us 3x squared equals 34. And then we are going to divide both sides by 3. And this gives us x squared equals 11.3 repeating. So we're just going to call that 11.3. And then we are going to take the square root of both sides. And the square root of x is x. And again, the square root of 11.3 is positive or negative 3.361,547, on and on and on. And again, we're going to round to the nearest hundredth. So the 1 tells the 6 to stay. So our answers are x is approximately positive 3.36 and negative 3.36. All right, our last example here. Let's go ahead and take a look at what this looks like when we're solving a real life problem. It says here, a touch tank in the shape of a rectangular prism has a height of 3 feet. Its length is 3 times its width. The volume of the tank is 270 cubic feet. Find the length and width of the tank. So if you're wondering what a touch tank is a low open aquarium where you could reach in and touch some of the aquatic life in the aquarium. So they tell us that the height of the tank is 3 feet and that the length is 3 times its width. So we only want to use one variable. So since we're going to use W for width, instead of writing L for length, we're going to write 3W because the length is 3 times the width. So now we know that the volume of a rectangular prism is length times width times height. So here we have our length, which is 3W, times our width, which is W, times our height, which is 3, and that is supposed to equal 270. Then we can multiply these together. 3W times W is 3W squared. And 3W squared times 3 is 9W squared. So now we have 9W squared equals 270. Next, we want to divide both sides by 9. And we get W squared equals 30. Now we want to take the square root of both sides. So we get W equals positive or negative. And again, 30 is not a perfect square. So that becomes 5.4772255 and so on. But we have to do two things here. Number one, let's go ahead and round to the nearest tenth this time. All right. And so 7 tells this 4 to become a 5. And the other thing to recognize is when we're talking about measuring real life objects, can we measure the length of a real life object in negative numbers? No. So the only answer here that counts is the positive answer. So the width of this tank is approximately 5.5 feet. And the length of this tank is going to be 5.5 times 3, which is 16.5. So there are the length and width of this tank.